Moving forward, please join me in welcoming this panel on heliophysics decadal discussion, and welcome our moderator, Joseph Westlake. Dr. Joseph Westlake is the director of NASA's Science Mission Directorate's Heliophysics division at NASA headquarters, where he leads a world-class team in understanding the Earth's most important and life-sustaining star. He's a graduate of the University of Michigan and a PhD in physics from the University of Texas at San Antonio. So with that, Joseph, take it away. Thank you.
Yeah, so let's see here. Maybe. I think so. Can you all hear me? Yeah, I think that's perfect. Thank you so much. I actually asked them to turn the mic off, that I would just, but I think it's better with it on. Anyway, I'm actually going to pass it over to these to the actual moderators. Ian and Georgia, I don't know if you want to introduce yourselves or
Yeah.
push in that direction.
Yeah, let me just start.
Go for it.
Yeah, so I just wanted to say that we actually have a really good panel today with representation. Okay, thank you for doing it. With representation, from the from NASA and NOAA and the Applied Physics Laboratory. But I also want to say that the sponsors of the Decadal also included not just NASA and NOAA, but also NSF and the U.S. Air Force. And we weren't able to get them to be a part of this panel today, so we're going to do our best to present our perspectives, unbiased perspectives on that. I also want to point out that NOAA and NASA have not really provided their formal responses to the Decadal. We are all working really hard to ingest and interpret and plan for this next decade. So just bear with us as we work through those conversations. And then I think as we start to talk about the Decadal, you will find that a big part of this Decadal survey was space weather. But because we have a panel that's going to be coming up next that is really dedicated to that, I think we're going to focus a little bit here on the science and also a little bit on the policy. So with that, I was going to, go around and introduce. You can redo yours if you want to add more to that. I think I'm just going to start myself. I'm going to be the moderator today. We're going to start with a set of questions, and then we'll open it up for some questions from the audience. I am a research scientist. I've been at Goddard for 25 years. I started as an astrophysicist and then went over to the Heliophysics Science Division in 2010. I'm really interested in understanding energetic particles and building detectors to measure energetic particles, and super excited about the applications of our technology for Artemis, the Moon, and Mars. In my long career, I have had several roles as the deputy project scientist for the ACE and Stereo mission and the mission scientist for IMAP, and now I'm serving as the manager for the strategic planning and opportunities capture for the Heliophysics Science Division. And so with that, I will turn it over. Joe, do you want to start over again?
Yeah, I mean, I'd be happy to. That's fine. My name's Joe Westlake. I'm the director of heliophysics at NASA headquarters. I have worked in the field for quite some time. I've worked on planetary magnetospheres. I've worked on MMS. I've worked on many other missions along the way. And I think that's it. I'm just over a year at headquarters and super jazzed to be here.
Great, thank you.
Yeah.
Ian?
So I'm Ian Cohen. I'm at the Johns Hopkins Applied Physics Lab. I've been there about 10 years. I started as a postdoc. My expertise is in energetic particle dynamics and Earth and other planetary magnetospheres. At APL, I supervise our solar and space physics group, which is about 50 heliophysics researchers that do everything from the Earth's radiation belts to the sun to the outer heliosphere. I was also a member of the Decadal Survey Magnetospheres panel, and I informally lead a group called the Heliophysics Coalition, which is a group of institutions across the community, as well as AGU and AAS that help advocate for heliophysics research and funding.
Awesome, thank you. And Rich?
Oh.
Maybe get closer, does it work?
Okay, here I am. My name is Richard Ullman. I'm actually Deputy Director of the Office of Space Weather Observations at NOAA NESDIS. For a couple months now, I've been acting director. The Office of Space Weather Observations is one of three major program offices within NESDIS responsible for satellite development. And our responsibility is satellite development for space weather environmental observations in all orbits. So I'm very happy to be here.
Yeah, great, thanks. All right, so you can see that we have a great panel today. And I just wanted to start out by saying, for me, how, amazing I think and tremendous it is to see our scientists coming together, our brilliant scientists, to have this community-driven effort where we come up with the vision for the next decade through our decadal survey. So it's, many, many white papers and meetings and subcommittees that all come together for this process. And I'm just really proud of that process. So starting with that, the other thing I wanted to say is that for me, what was really exciting about this survey is how the panel really described heliophysics in its dual nature. Right. So on the one hand, we are striving to do amazing science, to really understand the fundamental processes at the sun and how they actually affect and connect to our Earth and other planets and even beyond. And then to use that local laboratory to understand other stellar systems. And then on the other hand, we actually have to strive to really, we're charged with, if you will, to really safeguard our home in space. So, this is a really, we do that, of course, with state-of-the-art research in space weather. And I actually think this mirrors our mission at NASA as well, right? So we are there to explore the unknown and to innovate for the benefit of mankind. So, it is a really unique field where we can actually do things on the same platform at the same time where we're doing groundbreaking science and also trying to understand space weather and safeguard our astronauts and space assets. So that's my segue into the first question for our committee. And so what I'd like to do is start with you, Joe. And this is really going to be for all of you. What are you most excited about the decadal?
Yeah, thank you, Georgia. So building off of the successes that we've had from the previous decadal, I don't know if you guys noticed, but we launched a couple of things in the last couple of weeks, right? Yeah, go punch, right? Go easy, go Lexi. This whole Class D experiment that we've done in risk as far in heliophysics is really paying off, right? We're watching the fruits of our labor go into space. We're watching that bold vision of getting to space faster, a little bit more scrappy, getting to, more innovative techniques. We saw with the ride shares, we saw with the transporter, we saw lots of different straightforward access to space. Really, really excited for what we're going to see out of the innovative look at the solar wind that we're going to get from Punch, right? Really excited about the innovative look at the auroral electrojets that we're going to get out of EASY. Really, really excited about some of the new views of our magnetosphere that we'll get from Lexi. And then, we're sort of ramping into this new decadal, riding the wave of the Solar Max, right? So Solar Max is providing us with so much activity, so much, focus on what is happening in the societal benefit, the community, the users in space weather. And you saw a huge flavor of that in the decadal survey, right? We're not just doing space science. We're not just doing heliophysics for our own benefit, for us to go and try and figure out, the nuances of what the sun or the upper atmosphere are doing. We're doing it to serve humanity. And humanity is more and more reliant every day on space-based assets, right? We heard the folks who came from Space Weather Week, we heard that during the storms last year, some 5,000 plus satellites did a mass migration autonomously during one of these events, right? Like you might need an air traffic controller in that regard, right? You might need some predictive capabilities in that regard. And I feel like what was laid out in this decadal survey sets us on the pathway for that. The other thing that I'm really excited about is the aspiration, right? We didn't go into this decadal survey and say, here's the sort of scrappiest thing that we could maybe do if we had a little bit here or there. The vision is, here's the next things that we need to do in the science to solve the science, to get us to a point, the next point along the road, to really understand the fundamentals of our connection to the sun. That aspirational vision that was put forward in the decadal survey is what we must do. And it's the thing that is next for us, right? The aspirational vision, whether it be, connecting the sun to the earth via the magnetosphere, understanding, the links between the two, or really understanding our upper atmosphere with GDC and dynamic, right? For the first time, having that dynamical view of where space traffic is actually occurring, where space weather meets terrestrial weather, or for the first time putting eyes on the poles of the sun, right? These are all huge aspirations that we must have. I mean, just think about that. The sun, our closest star, we have never seen the poles, period. I mean, that seems pretty fundamental and shocks me every time I think about it. So anyway, I'm super jazzed, super excited. There's a lot in the document. There's a lot of great things that came from the community. And I only hope that we can put together a plan that gets us through that decadal survey like we did with the last one.
Awesome. Yeah, and Ian, what about you?
Yeah, so a couple things. So I think the first thing is just the incredible input that came from the community and putting it together. It broke records that we've seen from all previous decadal surveys. Over 400 community white papers came in from researchers, really both inside and outside the community, right? A lot of outside experts trying to advocate for why other aspects of things that had not traditionally been part of solar and space physics should be under the purview of solar and space physics. And so, you know, just seeing all of the great ideas that came through and the real diligence that the committee put together in collating all of that into a really coherent and, you know, not too long decadal survey. But I think, you know, this decadal really does kind of represent the community kind of coming of age, right? This is a field now that's been around. It's relatively young as far as space science fields go. But, you know, we've seen this move now over the last 20 years since the first heliophysics decadal survey that really went from kind of point systems, right? A singular spacecraft going somewhere and making exquisite measurements in a relatively new environment to now the community evolving to having this systems wide approach, right? We've looked at the sun, we've looked at the solar wind, we've looked at Earth's magnetosphere and upper atmosphere, but now we're moving beyond just looking at each of those in isolation and trying to figure out how do they all fix together in this integrated system of systems. I think that's something that, you know, as we look forward to the next 10, 20, 30 years, we're going to have to go away from that kind of singular, you know, new observation in a new place to innovative observations that try to take into account all of the different things that are happening. I also think that there's a lot of opportunity embedded in the decadal survey, whether that's going to new places. If you dig down through the report and some of the appendices, things like very low Earth orbit, right, is a new frontier for the science that kind of at the edges between heliophysics and Earth science. Going potentially out beyond the edge of our solar system, out into the local interstellar medium is the kind of forefront between heliophysics and astrophysics. Going to other planets and looking at the space physics and heliophysics environments there, like potentially going to Jupiter, is the forefront between heliophysics and planetary science. And then, of course, all of the new space opportunities, right? Looking at large constellations, being able to utilize that opportunity and new instrumentation that might come on board to be able to kind of fit together all of these disparate pieces as we try to kind of flood everything under the sun.
Yes, exactly. Yeah. And Rich, what about you?
Yeah, for me and from the NOAA perspective, I think the exciting thing was already touched on by our other panelists. This is the first decadal survey where the community made a careful consideration and made some really important recommendations to NOAA and how NOAA could improve its services in space weather, and to connect the curiosity-based research that is done by the research agencies into the applications that protect lives and properties on Earth. That is part of our mission here at NOAA. And what's really gratifying from that is that it really mirrors many of the things that we've already started to do at NOAA. And so the validation that the things that we started to do in response to legislative and administrative priorities like the Pro-SWIFT Act and others, looking at how we could become a continuity baseline for fundamental measurements of the space environment for space weather. And seeing that reflected in the decadal survey, I think that was very exciting for me.
Great, thank you. Yeah, I'm excited about the fact that the decadal is asking us to work more together. So it's really fantastic. So that leads us to another question, which is going to be for all of the panel members again. And so this one is the charge to the decadal survey was to come up with a program that was ambitious but realistic. This includes a doubling of the NASA Helio budget over the next decade and establishing a more than $100 million space weather research program at NOAA, So the question really here is, do you feel that that hit the mark? And Rich, I'd like to start with you.
I think it's very ambitious. So in that sense, yes, it did hit that mark. I think from my perspective, one of the greatest challenges in implementing from the Decadal survey has to do with maintaining the momentum that we've already started at NOAA as we grow from the research heritage where we were making use of observations that were put in place for research use, and then we taking advantage of that to make up forecasts and watches and warnings, and then building that into this concept of continuity of observation. So to leverage that, it's critical that we maintain that momentum. I think another ambitious recommendation from the survey was the creation of that dedicated applied research program that you mentioned. And it's really an exciting opportunity to bridge that gap between the cutting edge physics and the development of real world forecasting tools. I think that it's going to be a challenge to secure the resources and foster the collaboration across the agencies, but I think it's something that we need to rise to that challenge.
Great, thank you. All right, Ian, what do you think?
Well, to amplify what Rich said, I definitely think the ambition is there. This is a forward-looking decadal survey that really does try to bring together not just a singular agency, but multiple agencies, really the entire community, from the ground-based observers to the space-based observers, trying to integrate all of that great science and put that into a framework that I think looks towards the future, right? A big part of that is thinking about how do we get all of our data to work together, regardless of where it comes from, platform, agency, any of that, and try to figure out how do we set ourselves up for doing the science of the future. Where we just had a panel where there was a lot of discussion about AI. That's certainly an area where the community is looking towards. How do we think about the infrastructure of tomorrow, whether that's data support or analysis, to be able to do that? I will say, I think the definition of realistic might have changed since the decadal kicked off in 2022. But that is something that it's better to be ambitious and have really compelling science cases, and then figure out how to implement those on the back end.
Great, yeah, and Joe?
Yeah, I mean, we're going to have challenges in implementing this decadal survey for sure. But with any challenge comes an opportunity, right? So what's the opportunity that we have here? We, in the last decadal survey, we said, hey, we actually need to move from this model of having lower risk, large, capital F flagships or large programs in this way to embracing a much more risky approach, a Class D approach. And we're seeing the fruits of those labors right now, right? And the fruits of those labors, in the next year, we're launching 5 times in heliophysics, right? That's a big deal. I mean, think back to 10 years ago. Would we ever launch 5 times in 1 year, right? So I asked the question, with the dollars entrusted to us by the American taxpayer, what can we do in the next 10 years? And I ask that not because I believe that we must have more, we must do more. I believe that we can innovate in a way that gets us to what we need, to what we desire and what we have put down in the science. And I would challenge the community to come forward with ideas that get us there, whether it be embracing higher risk, whether it be pushing into, our new space collaborators, whether it be many other ways forward that we could really turn this amazing science that's been laid out in the decadal survey into an implementable plan. I think we can do it. I mean, I really do. And I think a lot of that comes with, we might have to figure out new ways of doing things. Yeah.
Yeah, I really like that approach. I think we're going to have to be very creative and innovative in terms of addressing the budget constraints that we have. So given that we are facing some real constraints, the next question, which is also for all of you, is what are the largest challenges that you see in implementing the decadal recommendations that are not related to the budget? So maybe I'll start with you, Ian.
Okay. Yeah, so as somebody who doesn't have any control or impact of the budget, I'll say I think I'll leave the agency parts to Joe and Rich, but I think one of the important things about getting the Decadal to be implemented is about the workforce, right? It's about getting the research community of tomorrow up and running, right? So making sure that we have a great pipeline for future leaders, future heliophysics researchers, so that they're ready and well prepared to be able to implement the vision of this decadal and the next. That ties to funding, of course, but it also ties to our institutions, right? Our universities, making sure that they're well supported and that they have the curricula, and also, of course, the faculty and positions that are required to bring on that next generation. I know there's a lot of students in the audience, right? Like we want to make sure that they are in the community, and it doesn't necessarily mean being a PhD space physicist, right? One of the things that the Decadal talks about is that it really does take a wide community with a lot of different talents, whether that's research software engineers that are looking at AI and how we implement that, or engineers that are across aerospace and electrical engineering, mechanical engineering, right? People who are going to work on the propulsion systems for these rockets that are going to get us there. It really does take more than just your typical scientist to do this work. And I think that's something that we need to make sure we cultivate so that we have that on-ramp.
Yeah, thanks, Ian. I think you're right. It's academia, it's industry. I mean, it's the whole thing has to come together. Rich, would you like to comment on this?
Yeah, so I guess when I look at the need to collaborate across all these domains, to me, NOAA's role, as I mentioned before, is creating this baseline set of continuity measurements. And traditionally, NOAA has done a good job of in terrestrial weather of disseminating that data. But with space weather observations, we've been a little bit less successful in terms of creating the common data formats, common metadata, common distribution systems. And I think that there'll be a real challenge there in coming to some community-wide understanding of and NOAA's ability to distribute that data for those uses.
Yeah, great. So maybe working with your other agencies to kind of figure out what we really all need and our users, right?
Yes.
Yeah, exactly. Yeah. And Joe, would you like to comment on that?
Yeah, I mean, I think the biggest challenge facing us out of this decadal survey is unifying our community. That came out as one of the recommendations, that we don't have a singular term with which to unify the community behind, that we're on our third decadal survey and we still can't figure out what we're named. I think that's a really big challenge, right? If that's truly the case, right? If we don't believe that our community is bounded by, the idea of heliophysics, which is the science of the sun and everything that it influences in our solar system, and space weather, which is the key application, the application domain and the societal benefit domain of what we do in heliophysics. If we can't, as a community, unite behind that idea, then everything in the decadal is going to be a struggle from here going forward. And I think that, the decadal laid that out. It laid out a bold vision. And I think that we as a community, if united behind that bold vision, could do amazing things together. But if we as a community are going to have a conversation over what we're going to call ourselves and use, spend the first 5 years of this doing that, I think we're going to move a little slow. So I hope that not to be too pushy, not to be too, forward in that regard, but I think the time is now in which us, we as a team, we as a community, and especially right now when stresses are coming from all directions within this community, it is essential that we work together as one heliophysics community. And I mean, a huge kudos, to our NOAA colleagues in that approach of one NOAA. I mean, you think about that, we've talked about one NASA, one NOAA. I really believe that we can do great things together, and we have to approach it in that direction. We have to put on the big hats. We saw the Decadal Survey committee did that. They, over and over again, we heard cases of folks within the Decadal Survey saying, you know what, the thing that I do that's in my heart isn't the most critical thing for the field as a whole. So I would encourage us all to put on those, put on the big hats, to put on the big ideas, and to be here for heliophysics, be here for our field as a whole. So I think that'll be the biggest challenge. I hope we can do it.
Thanks, Joe. I mean, just to add to that, I think, part of that, probably that problem is that we're such a diverse community, right? And we span a whole bunch of different domains. We have very large data sets. The data that we need to take spans orders and orders of magnitude in terms of the scales that we're looking at. So we have to overcome the fact that we have, such diverse science and bring us all together. So I really do agree with that.
Your comments dead on, but the key in that, right, when you talk about diverse is that, the coming from broad backgrounds and other places, you're pulling scientists from different areas of expertise. That umbrella, right? Our team includes that.
That's right.
It's a big
That's
deal.
right. It's a big deal. Exactly. All right, good. So and now we're going to move to another question that's actually just for Joe and Rich. And this one is, the Decadal survey recommended an enhanced coordinated multi-agency space weather research and operations program, that's in quotes, and would, quote, demonstrate the strong research to operations to research, R2O2R, and of the Heliosystems laboratory. Overall, there was an emphasis on integrating all of the data into an overarching Heliosystems laboratory. Can you share ways that your agencies are already working together, which could potentially lay the groundwork for future collaborations? And maybe I'll start with you, Rich.
Yeah, thank you. So I think that the groundwork is being laid and has been laid. I think there's several successful research to operations observation sets that we can point to, and one of the most recent is our new coronagraph on GOES 19. This was up until now, coronagraphs were research instruments. NOAA understood that the really important operational benefits of coronagraphs, and has worked with Naval Research Lab to build a coronagraph for operational use. We launched it last year on GOES 19. It just recently received provisional operational status for the data, and that's been a huge success. Our second coronagraph will be launched on SWIFO this coming September, and so that's moving that research observation into a resilient operational cadence. A second example would be with the Punch mission, which was launched was it last week or 2 weeks now?
March 11th.
Yeah, thanks.
It wasn't, well, yeah, exactly. So with Punch, really exciting mission with polarimetry of coronal mass ejections. And we think that at NOAA that it's got some real potential, but there's no operational history there. And so what we did was we at NOAA made an investment with the PI to develop a quick look product, which we call Quick Punch, that will demonstrate the possible operational usefulness of this data set. So I think making those sorts of investments in NASA research, taking the results of NASA research and operationalizing it, I think those are the things that we've done in the past and that we can do some more of.
That's great. Yeah, Joe, would you like to add to that?
Yeah, I even want to riff off of Rich's comment on Punch, right? If you look at Punch and you look at how Punch ended up where it is, right? We started with SOHO. We started with various measurements prior to various coronagraphs, various ways of looking at the upper atmosphere. Those were research topics that we're really trying to get to the cutting edge, right? Punch is a new way of doing, the connection of the corona to our Earth. And one of the amazing things that I think we've done out of that is that, we hope obviously to get first light from the instruments and get the great science that's coming soon. But one of the amazing things that our colleagues at NOAA have done is, they've picked up that coronagraph technology in the research in both the data realm, but also, using that kind of technology for your next, for SOL, right?
That's correct.
That is the approach. So you think of research to operations, and I would encourage that there's many different ways for us to do that. We do that in the hardware sense. We're already doing that. We do that in the data sense. We're already doing that, right? But I think that there's also additional ways forward for us, right? Where the research, the tip of the spear things are happening from the NASA, we're taking the risk, we're pushing that forward. And then we're working in concert with our colleagues at NOAA to find ways to then take that into the operational sphere, to turn key insights that we've gotten into an operationalized thing that serves and benefits humanity. And I think that our close relationship between NASA and NOAA has only grown closer over the years. And I think at this point, we're getting to the point where we can actually structure our programs together to benefit humanity in a really wonderful way.
Yeah, and that reminds me also, we can share access to space.
Yes.
And
Yes.
and in fact, the SWIFO launch this September is a contribution from NASA as a ride share as they launch IMAP to L1. We also can consider and we have considered the potential for instruments of opportunity such that we could host research instruments that could be provided by NASA or other research agencies on our operational missions. So looking for more of the access to space for research and observational missions is another way that we can pool our resources.
Yeah, absolutely.
Yeah, that's great.
Absolutely.
And I think I even want to bring it out, it'll be a little bit broader because we don't have NSF and we don't have,
Yeah, yeah.
the Air Force here either, but we actually have a lot of data that we need to pool and a lot of opportunities to take more data. And so, one of the mentions in the Decadal, of course, is that heterogeneous approach, where we need to combine our ground assets and our space assets together. And so we're looking forward to ways in which our other agencies can work together to kind of pool those resources. Okay, so the next question, which is also for Joe and Rich, is the booming new space commercial industry was highlighted in multiple places in the Decadal, including taking advantage of the commercial data buys. Can you speak to how your agency may take advantage of the capabilities and opportunities within industry? Joe, do you want to start with that one?
Yeah, I mean, I would say that we're already moving in that direction in many ways. I think the key example of that is if you look at the Escapade mission, right? Escapade is a totally new way of doing the solar winds interaction with Mars. We partnered with some industry partners, Rocket Lab, Blue Origin, others to have a university PI-led, high risk, high reward mission put out there to go towards Mars. I mean, we're sending 2 spacecraft to Mars on the cheap in that regard, and it has a ton of risk around everywhere. But that's what new space is to some degree, right? I mean, you see failures happening frequently within the new space realm, but the successes are immense, right? I mean, whether we think about Blue Ghost, I mean, think about that, right? We put what, 10 instruments on the surface of the moon off of a commercial lander, a commercially provided service to the surface of the moon. What could we do with commercially provided access to LEO? What could we do with commercially provided things that are in that realm? And I think our colleagues at NOAA have more experience on the data buy side, but why are we competing in places where industry is already has excelled there, right? I think that's a big question for us, an existential question for us. But at the same point, if the data products aren't there and if the new space industry isn't there, how do we get them there? How do we incentivize? How do we make it so that piece of it is going to happen in the way that our scientists need it, in the way that our society needs it? Yeah.
Yeah, very exciting time. What about you, Rich?
Yeah, Joe mentioned our commercial data program at NOAA, and we did run our commercial data program has sort of 2 phases where we do demonstrations. We purchase data to see how useful it might be for operational use. We did a commercial data pilot for space weather ionospheric radio occultation. That was pretty successful. We have a report that will be available to the community soon on that. But we've already moved forward to a commercial data buy for operational use of radio occultation data with Spire and Planet IQ. So that's one way of commercializing. NOAA is also looking at commercialization in the ground systems and how we operate our missions. And so we've already been using commercial antenna services around the world. We're looking at potential, some not within space weather, but in some of the other programs at NOAA, looking at commercial operation of our assets in space. And I think that that is a place that may grow. And certainly we've looked at for data processing in the cloud rather than in our own purpose-built systems. So there's a lot of area for commercial engagement, including everything from data buy to the ground assets. So it's there's a lot of really mature commercial capabilities out there.
It's great. And I'm hoping we'll hear from the audience after our set of questions on this one as well. And Rich, I think I want to have a follow-up for you as well. So the Decadal specifically highlights or recommends that NOAA should quantify the contribution of potential new data sources that can be used to forecast, as well as quantifying the specification accuracy, which can be done through observing system experiments or observing system simulation experiments, or OSSEs. The use of OSSEs is commonly seen in terrestrial weather forecasting. Can you speak to what that might look like for space weather?
So we're developing the capability for OSSEs as well in space weather. I think that the commercial data pilots are one area where is an example of how we can analyze the contribution of products through looking at new data streams that might be available. We also have had experiments, which we call joint ventures, that have looked at new data streams. In particular, I'm thinking of a joint venture that we did with SpaceX to look at Starlink data. As was previous, I think Joe mentioned that during the Gannon storm, approximately 5,000 spacecraft made maneuvers to compensate for greater drag. Many of those, or probably the majority of those, were Starlink satellites. In our joint venture, SpaceX provided the orbit ephemerides for Starlink for a set of data, and we looked at whether we could derive atmospheric density from the experiences of those thousands of spacecraft in low Earth or very low Earth orbit, and the results are pretty promising. And so we're looking at perhaps moving on to developing a way to ingest and assimilate that data in near real time with a cooperation with industry. So those are the kinds of things that we can do to bring in new data streams.
Yeah, very exciting. Okay, so I have a question for Joe. A major emerging theme of this decadal was looking at heliophysics relevant science from cross-divisional science opportunities. Examples of this cross-divisional research, including the Sun-Earth connection to inform habitable worlds, and working with Earth science to develop whole atmospheric models. And of course, I think Artemis is inherently cross-divisional. So there are current concrete examples, such as the work that Heliophysics Division has done already with ESCAPADE mission and to Mars, and taking over the RAD instrument with Curiosity. So how might HPD and SMD approach the challenges within NASA that might inhibit this?
Sure. Yeah, I mean, if you look across NASA science, we do important work for the American taxpayer. We do important work that achieves the greatest science. The greatest science comes whether it's within heliophysics, whether it's within planetary, whether it's within anywhere. It is achieved by NASA science. And so when I look across the divisional landscape and you look at the next things to do, many of those things are cross-divisional, right? Habitable Worlds touches on so many different pieces of the NASA science portfolio. That is a big deal. Mars sample return touches on so many different pieces of what's going on across our portfolio. Like, think about all of the big things that we could do. Solar Polar addresses huge pieces across the entirety of the NASA science portfolio. And you know, whether it be studying our star as an example of stars, right? Why would you do heliophysics to understand astrophysics? Or why would you do heliophysics to understand Earth science? Looking from, you know, dynamic, trying to understand that true connection between terrestrial weather and space weather. You know, heliophysics exists at the interfaces of every other division within NASA science. And I take it to some degree as our charge to be some of that glue that keeps NASA science connects the pieces between them. And I think in many ways, the scientific measurements, the scientific approach that folks have put forward in the Decadal survey lays out a vision of that. And it's cross-disciplinary. Look, I mean, I want us to be heliophysicists. I want us to be a one heliophysics community, but really what I want us to be one NASA science community, right? One NASA science is putting on the even bigger hats and thinking about what's the most important next thing for us to do in science. Yeah.
Great. It's exciting. Not only are we able to do safeguarding and good science, but we're really cross-divisional. Okay, so last but not least, I want to address another question. It's kind of returning back to something that Joe had already said. And so this is for you, Ian. One of the interesting topics that Decadal addressed was the lack of common name for the field, specifically including that a common name, so this is in quotes, a common name for the field that can be broadly called solar and space physics would improve efforts in data gathering, recruitment, education, and public outreach. So how do you think this issue has impeded the community in advocacy and outreach efforts?
So, yeah, I mean, I don't think it has, to the extent that I think the Decadal maybe implies that it did. We saw in this past year between solar eclipse that captivated, 12 million plus people, I think it was, on NASA engagements across the country. Two pretty significant geomagnetic storms. One was the largest in the last 20 years in May 2024. I think the natural phenomena have been well aligned for us at this time to be able to capture people's imagination and excitement. I think as far as a name goes, it's much more important for the community to be unified under a common vision, a common set of compelling science questions, and the excitement and the passion that goes behind those than it is about a name, right? It doesn't, when I've gone, to speak to policymakers and stakeholders, they don't ask, well, what is this community called, right? We come in, we might say we're talking on behalf of AGU or AAS and the divisions or sections within them that represent the space physics community. But if anything, the term heliophysics, as an example, is a talking point, right? We come in kind of jokingly saying, have you heard of heliophysics? And, many of them have, but the few that don't, it's a way for us to start that conversation. Well, it is X, Y, and Z. And they understand that. They get excited about when we show them pictures of the sun, when we show them incredible videos of the aurora. They're more engaged and captivated by the passion that is brought with the people that come and do these advocacy and outreach things, right? It's when you hear an engaging speaker, right? It's not the name or the title of their talk, right? Or their title that captivates you. It's the passion and the energy that they bring, right? If they care about the topic, it helps you care about the topic. And that's, I think, a much more important thing for us to really be able to convey, is that we have very compelling science in solar and space physics. Doesn't matter what we call it, it's compelling. Right? There's broad relevance. Right? We can do space weather, which has that societal application, but we are also at the forefront of all of these different other science divisions. We can talk about everything from, the sun is a star. This is kind of astrophysics at our fingertips. We can talk about the application to climate and impacts there, and earth science. We can talk about going to Jupiter, which has the most intense radiation belts in the solar system, or Uranus, which is kind of this topsy-turvy world that we haven't explored, right? Heliophysics, space physics touches all of those different things. And, I think one of the things that we've talked about is trying to bring together as many different partners in our advocacy efforts as possible, right? So it doesn't really matter what this department's called over there, or what this agency's division might be called. It's having the folks in the room to coordinate so that we can make sure that we have a unified message, right? That's the most important thing. So one of the things we've been doing over the last couple of years with the Heliophysics Coalition is bringing together those institutions, be they, R1 universities, small business, larger businesses. We do have industry partners. We'd love to get more, but making sure that they're all working together and talking to each other so that we can make sure that when we message and communicate and advocate, what it is that we are, right? What it is that we are as a community, what we're hoping to do, that we're speaking with the same voice.
Thank you, Ian. And I'm going to show my bias. We're still in the heliophysics big year.
Yeah.
Okay, so now I want to just
I
open.
want to add a little bit.
Good.
So I think that for us, where we look at the application area, I think that there's a great benefit, as Ian was saying, in being able to introduce ourselves and people say, well, wait a minute, what is that, right? So when we talk about space weather, some people are sometimes confused. They're like, space weather? But the point is that from the aspect where we are at NOAA, where so much of NOAA is about weather, and the environment, we translate the environment into weather impacts. It really is useful for us to call the field of application space weather, because it has so much of that same connotation. We talk about storms, we talk about how storms impact infrastructure, and those come across a little bit easier when we're not talking in research terms. So I think that maybe there's a challenge to the community to understand the interconnections of all these different names and why the names are important for the different ways of looking at the phenomena.
Yeah, I agree with that. So now we're going to open it up for questions from the audience. So any questions?
Yeah, hey, this is a very interesting question for you about kind of the interplay with the DoD side of the house. How would you grade the relationship between kind of the civil and the DoD side? Is it a working relationship? Is it kind of hit or miss or ad hoc? And maybe thoughts about how to improve that over time. Anyone?
I'll start. So this is definitely something that we do at the Applied Physics Lab, right? We work with many national security space sponsors, and in addition to NASA and NOAA and NSF. I think one of the areas there's a lot of growth. I think many of us up here just came from Space Weather Workshop out in Boulder earlier this week, where we saw a huge national security presence. There's the growing interest from the national security sector in space weather and space environment, and heliophysics to that point is growing. I think the biggest piece that needs to happen still is some of the translation, right? We talked a little bit about the messaging between NASA and NOAA. If you compare the NASA and NOAA messaging versus the DoD civil space messaging, it's much better. So helping the end users in the national security space environment understand that when we're talking about space plasma physics, when we're talking about heliophysics, it's the same science that they care about. It's the same expertise. And this is one of the things we actually use when we're talking, when we're advocating, right? Is that the science of space weather, the science of heliophysics is the same science as nuclear fusion. It's the same science as hypervelocity hypersonics. It's the same as plasma physics, right? It's all the same. We want that skill set. We want that understanding domestically, right? So that we can maintain our competitive advantage in the world. So I think it's still a question of how do we get that interface between national security and civil space to work, because the researchers are very focused on their science, and they have yet to effectively get to a place where they can understand what exactly it is that the end users need. A big part of that is clearances, right? Not many researchers have clearances. They can't know what it is that needs to be known or what problem needs to be addressed. But I think there's a growing desire from the community to be helpful. So venues like Space Weather Workshop we just came to, APL hosts the Seasons Workshop, which is more national security focused space environment interactions. Bringing together the research community with those national security end users, I think, is the key that we need to enhance over the next couple of years.
Okay, yeah, that sounds great.
We have a Zoom, an online attendee question. So what synergies do you anticipate between the space-based and ground-based prongs of the decadal? Does the potential for multi-messenger science carry any weight in the funding recommendations made by NASA?
So I'll just, the funding recommendations made by NASA. So just a reminder that the Decadal survey is not the funding recommendations made by NASA. That they're funding recommendations that, or budgetary recommendations that come from the Decadal survey. I'll also note that it'd be great to have our NSF colleagues in this conversation,
Yeah.
especially when we start to talk about the ground-based assets. You know, our NSF colleagues over and over again have brought forward an immense ground support network, an immense ground network to drive innovation, to drive, you know, real science in that direction. And I think that, again, the way that we work in an interagency fashion, the way that we work across government really creates the opportunity for us to bring forward all key aspects of a scientific measurement, all key aspects of the physics to really understand the problem. And so again, I think that's really, you know, we should bring our NSF colleagues along in this conversation. And I think that they would have some really strong things to say about that.
If I could just chime in, yeah, you know, on the Decadal survey panel that I was on, one of the big emphasis that we had was, you know, let's not care about how we implement this, who does what, but, you know, what do we need to get this science of the magnetosphere to be achieved? And one of the things that we got really excited about in our discussions was, you know, oh yeah, we could do this thing in space that maybe NASA would do. Oh, but what if we added this piece on the ground, and think about how this could be synergistic if we could get this observation at this time in this location with that in situ observation from space. I think that being able to achieve that kind of integration, regardless of where the platform is, who's funding it, is the thing that the community needs to achieve and the agencies need to figure out. And they've done quite a bit over the last 20 years, but that's going to be the piece to unlocking kind of the next level of our scientific discovery.
Yeah. I mean, I'm just going to add that, you know, we really need a systems approach here, and that can only be done with combining those space assets and ground-based assets.
I would say that for our mission at NOAA, at the integration of ground-based and space-based is essential. I mean, it's one thing to say that a storm coming from the sun is geoeffective, but then you have to understand what that means on the Earth, what you know, the conductivity of the Earth in particular regions. How is this going to affect the industry, the power grids, and so forth. So yeah, it's essential that we consider those and integrate them together.
So, you know, I find it fascinating that the field has reached a level of maturity where we're looking at things at a systems level. So that's fascinating to me. And as a systems engineer, the question that comes to my mind is, what are some of the key sensitivities or systems level dependencies that we're looking at the level of the solar system? So I don't know, like for instance, if we change the trajectory of an asteroid, is that going to affect the radiation field of Jupiter? Now this is out there, but as we look at this as a whole system or system of systems, what are some of these key things that we're looking to study? And maybe I should read the Decadal survey, but
it all starts with the sun. So the more we can understand about the sun and the sensitivities it drives for all other systems in our solar system, the better we'll understand things. So that's my 2 cents.
So actually, I'll disagree. No, I mean, I think one of the, you know, obviously the sun is a driver, but I think one of the questions is, you know, we see in the geospace system, whether you're looking at the upper atmosphere, or you're looking at the magnetosphere, is that regardless of what hits the system, we see these same manifestations over and over again, right? The same thing happens. Substorms happen. The same auroral forms happen, but we don't really understand why the system defaults to that, right? Why is it that a coronal mass ejection causes this aurora to occur? And, you know, it doesn't matter if we get 1 coronal mass ejection or 3 coronal mass ejections that hit, we still see the same thing. And so understanding what it is about the intrinsic characteristics of the system, and, you know, you can expand that beyond Earth, right? It could be Earth, it could be Jupiter, it could be Mars. You know, what is it about these systems and their characteristics that causes these drivers to manifest these same things over and over again? I think that's one of the things, again, about systems of systems, because we've looked at the sun, we've seen what drives it, we've looked at the magnetosphere, we've seen what happens, we've looked at the upper atmosphere, we've seen the aurora, but how does all of this couple into this happens on the sun, and this is what we see over and over again in the system?
And And I guess from the previous panel, I was struck by the statements about how data sparse they were, and then thinking about our observations in heliophysics and space weather, were orders of magnitude more sparse, if that's the right way to go, than they are. And these structures that you're talking about that emanate from the sun, they're so large, and there can be major events that we happen to be in an eddy of, because we are so small. The Earth, the entire Earth system, is small related to the structures that are coming out from the sun. So there's a lot more to learn.
I think if you look at the strategic missions that NASA has put forward over the last decades, you can trace activity as it comes from the sun all the way down to the surface of the Earth, right? Whether it be you're watching the solar corona emanate into space and asking the key questions of what is the physics of that, and answering those questions with Parker Solar Probe, right? Trying to understand how energy gets into the magnetosphere through magnetic reconnection, answering that question through the magnetosphere multiscale, right? Figuring out how the radiation belts form and evolve with the Van Allen probes, right? Each one of these strategic missions, and there's many in that line that I didn't touch on, but each one of those follows a key connection between the sun and the Earth. And I think, and I see, in the Decadal survey, the next key questions to be had, right? How does the rubber hit the road when space weather hits the upper atmosphere with GDC and dynamic, right? How does energy really propagate through the system? How do we really understand the core ways that our system evolves with links? And then how the heck does the sun as a star work with solar polar, right? Really understanding the fundamentals of how a star works, and getting to the basics of that, and getting that fundamental understanding of crucial physics that drive everything that we see out in the universe. Yeah.
I'll also add, I think there's another piece to it too. It's not just the science, but I think the community, as we mature and try to look at the systems approach, and we're going to have these potentially large distributed data sets, no matter where they come from. I think the community also needs to mature, because to now we've had these kind of singular data sets that look at mostly in situ or remote sensing, and we have a very trained approach, right? We comb through the data, we find something interesting, we do analysis. Once we start talking about n number of distributed satellites, or I'm pulling data from this data set and that data set, we as researchers, we as a field need to mature to a way where we can have a more integrated approach to be able to analyze all of that data effectively. And it doesn't necessarily just mean machine learning or AI. Obviously, that's going to be a tool, but how do we look and ingest all this data in a way that kind of allows us to really unleash the full potential of what we're seeing?
Great. I think we have time for one more very quick question with equally quick answers. So, sir.
Okay, the quick question is, this is really a post-decadal survey question. Have you given much thought to doing heliophysics from the lunar surface when we get to have people on the moon, which is coming?
I got a super quick answer to that. We just did that on Blue Ghost.
Yeah.
We're flying heliophysics instruments on the lunar landers that are going on the CLIPS missions. So yeah, we are.
Okay. Okay, well, yeah, thanks for your attention, everyone.